Okay, test number 4, the tennis courts. Testing outside in the Canadian winter is problematic, so in February 2012, I obtained permission to do tests at an indoor tennis courts at my athletic club. The floor is perfectly flat, and I thought I might get lucky with the side scatter in this situation. So the borrowed equipment all had to be returned, so I used as a transmitter the handset of my 900 megahertz cordless phone at the time. I put the spectrum analyzer on a small wooden stool and proceeded to make measurements, 1 meter intervals like before, and here's the result. Well, it's unintelligible noise. It looks nothing like the asphalt tests, unfortunately, and this has to be caused by scatters in the concrete walls and the light fixtures and so on. So I decided to make the measurements at closer intervals just for fun, because I'm here, I'm set up, to try to resolve the noise, just out of interest, academic interest. So I repeated the tests, but at 10 centimeter resolution. So that's 10 times finer resolution than the first data set I just showed. And here's the result. It still looks like noise. So then I decided to do an experiment that I figured no one would do. Decrease the resolution by another factor of 10. So the measurements are now 1 centimeter apart. To do this, I taped a pen to one leg of the stool and taped a long tape measure to the floor so it wouldn't move. And I could move the stool 1 centimeter at a time with a precision accuracy of, I figure, about plus or minus half a millimeter. It looks like this. Okay, I recorded 20 seconds of spectra at 120 points. So that's 1.2 meters of spatial variation. So in summary, at 1 meter resolution, we see noise. Spatial noise. When I decrease the resolution by a factor of 10 to 10 centimeters, it still looks like noise. When I again decrease the resolution or increase the resolution by another factor of 10 to 1 centimeter resolution, it's not noise anymore. There's a strong deterministic signal here. Now we see a kind of an impulse-looking thing, and there appears to be a kind of a sinusoidal fundamental. The impulse looks to me like maybe reflections from several scatterers falling in step caused by a complex environment. But this sinusoid, that's different. There's a single scatterer, I think, looks to me, that has a high spatial frequency because, of course, the sampling is 1 centimeter apart. So maybe that could be a reflection off the back wall, and I measured it 76 meters from the transmitter. So after a couple of software changes, I simulated the reflection of a back wall. And bingo. The simulation of the concrete wall, 76 meters away, causes a sinusoidal amplitude variation that looks just like this. The measurements seem to show a similar fundamental signal, maybe mixed in with a bunch of other scatterers. I mean, it's not proof, but it's some evidence that the model has predictive value.